So next we're going to look at characteristics of polynomial functions. So again, we're going to start with some terminology. Recall that end behavior is a description of the values of f of x as x goes to negative infinity and as x goes to infinity. So what we're asking is, what are the y values of the graph approaching as x approaches infinity and as x approaches negative infinity? So let's take a look at two examples. So describe the end behavior for each function. So let's start with 2x minus 1. So if we think as x goes to infinity, as we get larger and larger x, we see that the y values also get larger and larger. So we can say as x goes to infinity, we see that y also goes to infinity. So next is as x goes to negative infinity, as we get larger and larger negative values, we also see that the y values get larger and larger in the negative direction. So this time as x goes to negative infinity, y goes to negative infinity. Alright, next one, g of x equals 2 to the exponent of x. Again, let's look as x goes to infinity, we see that y shoots off to infinity. So as x goes to infinity, y also goes to infinity. And if we look in the opposite direction, so as x goes in this direction, as x goes to negative infinity, notice that the graph here, remember this is an exponential function, so the y values are starting to approach 0. So as x goes to negative infinity, we see that y is going to 0. So all you're doing is describing the end behavior of the graph, nothing in the middle. Next up is turning point and absolute max and min. So recall that a turning point is a point on a curve where the function changes from increasing to decreasing or from decreasing to increasing. The absolute max or min is the greatest or least value attained by the function for all values in its domain. So let's identify some of the key points here. So we have 3 turning points for this graph. So we see that the function goes from increasing to decreasing, decreasing to increasing, and increasing to decreasing. So those are our 3 turning points. These would be points where we have a local max or local min. Shown here is what we call the absolute max. For this graph, we do not have an absolute minimum because this graph would continue on in the negative direction. So now, with these definitions, I'd like you to complete the following investigation. So copy and complete the following table. Use Desmos to graph each of the polynomial functions. And again, don't forget to adjust your window in order to see all the key characteristics of each graph. This time you're going to sketch the graph. You're going to state the degree. Remember, the degree is the highest exponent in the expression. You're going to state the leading coefficient. And remember that the leading coefficient is the coefficient in front of the variable with the highest exponent in the expression. You're going to discuss the end behaviors as x goes to infinity and as x goes to negative infinity. Then tell me how many turning points each of the graphs have and how many zeros. So how many times do they cross the x-axis? Once you complete that table, answer the questions that are listed below. Once complete, you should be able to answer the following questions.